What is multicollinearity and how to detect the multicollinearity in the dataset?
So multicollinearity is interdependency between the features. For example, you're predicting a particular value, you're predicting the sales or the loss percentage. Now there are two columns. One of the column is income in dollars. The other column is income in rupees. Now there are two columns in the data, but these two columns are not independent. If income in dollars is very high, obviously income in rupees will also be high because both of them are interdependent. If two variables are interdependent, now this particular problem is very typical in linear regression or in regression. So that will impact the coefficients. The beta coefficients will be impacted due to this multicollinearity. So you cannot really trust the beta coefficient value. Sometimes it may happen that a variable is positively impacting, but due to multicollinearity, the coefficient looks negative. So multicollinearity has an adverse impact on beta coefficients. So that is why it's a problem. So if you have two variables which are interconnected, you have to do in such a way that you have to keep all the independent variables only. For example, somebody told that I have built a model with 20 variables. Usually, what is the impression? If somebody says that I have built a model with 20 variables, people think that you have used like 20 variables. But when I look at the actual model, it happens that the first variable is x1, second variable is 2x1, third variable is 3x1. That means if there are several variables which are interconnected, those are not really 20 variables. If I look at independent dimensions, maybe there are only 10 or 15 independent dimensions, independent features or independent variables. So multicollinearity in simple words is interdependency between the features. One feature is dependent on multiple other features or any one more feature. The multicollinearity, if you want to detect it, you can detect it using a particular measure called VIF, stands for Variance Inflation Factor. You can calculate VIF by using regression technique only. Once again, you take that variable and use rest all variables for making a prediction. So that is known as VIF. So VIF formula is 1 by 1 minus R square, where that particular R square is a variable versus rest all predictor variables R square. So if the VIF value is more than 5, it typically means that that particular variable versus rest all variables, if you build a regression model, that is giving you more than 80% R square. It means that is a serious case of multicollinearity. We can consider dropping a variable which is having more than 5 VIF, but we should not drop in one shot. We have to drop the feature that has the highest VIF 1 by 1, 1 by 1. We have to remove all the interdependencies in the data.
So how do you validate a classification model? What are the different measures you look forward to validate this model?
So classification model is the most widely used model for most of the business cases, or most of the business problems are framed as classification problems. To validate a classification model, one of the first measures that comes to our mind is confusion matrix and accuracy. That is one of them. But when there is a class imbalance, if one class is dominating, the other class is having lesser number of records, then this confusion matrix and overall accuracy may not work. Then we go for something called class-wise accuracy, which is known as sensitivity, specificity. Or there is another way to look at it is we can also use recall and precision, recall of class 0, precision of class 0, recall of class 1, precision of class 1. Then there's a measure that mixes both recall and precision that is known as F1 score. We can validate the classification models by using F1 score as well. We can also create an ROC curve, the area under the ROC curve, AUC is another measure. Like that, there are several other measures, but these are the ones that are most widely used for validating the classification models.
Okay, so how do you go for validating a regression model?
So in regression model, the most widely used validation measure is R square. So we simply compare the Y actual value with the Y predicted value. So we can use R square. Apart from R square, there are some measures that are similar to R square. So basically at the end of the day, if Y actual value, Y predicted value, if they are nearby, then the model is good. So we can use something called mean absolute deviation, also known as MAD. We can use mean absolute percentage error, MAPE, or root mean square error, or sum of squares of errors, mean square error. These are the other validation measures which can be used in regression, but usually R square is the one that most widely used one. Apart from that, MAPE, mean absolute percentage error, is the second one that people use in general.
What is an outlier in a data and how do you detect it?
So outlier, there are some values in the data that are very far away from the rest of the data points. For example, if I'm talking about the number of loans, the number of loans in the whole portfolio, most of the time the number of loans are 2 or 3 or 4. for most of my customers. But there are a couple of customers whose number of loans are 50 or 40. Or if I take the example of income, most of the people in my portfolio are ranging from, let's say, less than 75,000 income. But there are some customers whose income is very high, okay, 3 times or 4 times than the usual income that we see in the portfolio. Those are known as outliers. Outliers are those data points that are far away from the rest of the data points. Maybe sometimes they are valid, sometimes they are invalid. But how do you detect those outliers? There are two techniques. One is the visual way. You can detect outliers by looking at the box plot. If you see the box plot, if the box is somewhat compressed, either in the lower side or in the upper side or in the middle, then there are outliers present in the data. Or a better way that I generally use is percentiles. By calculating the percentiles, if you see 99 or 95% of the data is falling in a range, but the maximum value is going too far away from the rest of the 95% of the data, high side outliers are there. Or 95% of the data is lying in a range, but there are low side outliers which are far away from the rest of the 95% of the data, then we detect the low side outliers. So we can detect the outliers by using percentiles distribution.
So how do you handle those missing values?
So there are multiple ways of handling the missing values. It depends on to what extent they are missing. If the missing value percentage is less than 0.01%, generally we don't really care about those. But if the missing value percentage is ranging around 5% or 4, 5, 6%, if more than 90% of the data is clean and available, the remaining less than 10% of the data is missing, then we go for imputation technique. We look at the average of the rest of the 90% of the data, particularly the median value, and then replace those missing values with that particular remaining data's median value. That is one technique, imputation. But if the percentage of missing is really high, for example, if 20% are missing, 25% are missing, now that is a serious issue. So we do the imputation, we replace that 20-25% of the data with the median value, but somehow we have to carry forward this information that 25% of the data was missing earlier. Somehow we need to tell, or somehow we need to remind ourselves, or we need to tell the machine learning model that 25% of the data was missing. We have to pass on that information. So we create a new variable, which is an indicator variable or a flag variable, which takes only two values, 0 or 1, missing or not missing. Whenever the data is available, 1. Whenever the data is missing, it's 0. So later on, we can use this variable in slicing and dicing, in the sense like when the data is available, what is the pattern in the rest of the data? When that is not available, what is the pattern in the rest of the data? So in a pivot table, for example, income is missing at 25%. When income is missing, what is the default rate? When income is not missing, what is the default rate? You can use that as some information. So when 20, 25, 30% of the data is missing, then we impute as well as create a indicator or a flag variable. If the data is missing like too much, 80%, 90% of the data is missing, and only 10% of the data is available, then it's preferred that you drop that feature, if you drop that variable totally. Max to max, if you want to get some information out of it, try to create a flag variable, missing, non-missing, 1, 0. For example, if income is missing at 90% of the places, only 10% of the places it is available, you just replace all those 10% of the values as ones, remaining 90% as 0. That's it. So you have the information of available, not available. That's it. You act as if you never have the information of income at all.